My name is Arturo Serrano and this is rendering and graphics programming. So what I did for question number one was to create a new class called Skybox. This is similar to the texture cubes that we were using. So I set up manually all the 6 faces of the Skybox. But the tricky part was the UVs are going to be inside out since we're texturing from the inside of the cube. Other than that, everything was similar. I also changed the position of the vertices defined by the length that I'm passing in the skybox. I already have run it. So right now I'm running the texture from the class. I found it online, so it's running on a 5 sites. Uh, and as you can see, it's all the edges are seamless. So there's no hard edges like on the or white lines in any direction of the skybox. And just to show off, I already prepared another texture. Here's the other texture that I prepared, so everything is seamless. There's no edges on the cube. Like even if I zoom in way too much, what I have on the draw scene is just the standard things that we've been using for the texture. It needed the camera, the view and the projection matrices, and also I'm setting on a different constant buffer the world data. I mean the world matrix data, and then I'm just setting to context the texture, and then I just render the skybox. What I did for question number two was to set up the terrain model function, and what this function does is to create automatically the vertices and the triangle indices for the terrain to build. So I follow some of the guidelines that the book provided, such as these 4 variables. The first two, the dx and the dc, they're guaranteed. They will guarantee that the terrain is going to be placed at the center of the world. So it's going to take half of the length on each side, on the x and the c side. And then for the UV values, it's going to repeat them, whatever value we're passing, divided by the length minus 1. Then I just store some of the values I calculate the image scale and the height scale. On the image scale is going to be the length divided by the side, and the height scale is going to be 256 divided by the mice height. So the 256 it's equal to the height, but I tried to use this value, but it got weird results. So I'm just hard coding the number. So I had a for nested loop and to calculate all the vertices. Inside the nested for loop, I'm setting up all the vertices. So for the x value, I'm sending the dx plus I. Then on the y value, I'm going to take the y trans and I'm going to add the value calculated reading the pixels in the texture or image. So for that, I'm using the texel index function that pinpoints the exact pixel with the right vertex or vertice. So for that one, I'm sending the site, the I divided by the image scale, and also the J divided by the image scale into the texel index function, and that texel index function was provided in the PowerPoint. So here it is. Then for the UV values, on the UV value, it's going to be du times I, and the B value is dB times J. And there's nothing more to it. Then for the triangles, this is pretty standard stuff as we did on the sphere. Remember, we have a grid on the sphere at some point, so it's the same code. Then on the any demo, I'm loading the texture on the MText plane. So I'm loading the HM test 16 and also on the terrain model. And I'm setting the size to be 16 with a max height of 2, placed at the very center on, so it's going to be 0 and also no UV value repeat. And I already have it running and it looks like this. It looks like the PowerPoint. And I've also prepared another texture. Uh, it's going to run the sandgrass texture. This one is loading the sandgrass TGA, but it's loading the bumpy texture at the HM test. And the size is going to be the same. It's going to be 16, but this time the height of the terrain is going to be higher, and I'm going to place it at -5 units, and I'm going to repeat each UV value by 4, and this is what we get. Let me scroll, zoom back, and it looks quite good, I would say.